So BGP path selection is not based on normal metrics like bandwidth or delay or hop count. It is based on something called rich metric called attributes. They are called as rich metric. The reason is they are too many, and they are attributes because they are plug and play. They are called as attributes. They are not called as metric because they are plug and play. Whenever you want, you can have it. Whenever you don't like, you can just leave it without configuration. So it's kind of plug and play. BGP attributes or rich metrics. They are not normal metric. It's like OSPF. If you take cost is the metric, you cannot take cost out from OSPF, or you cannot add something else to OSPF. It's only cost. It's not like that in BGP. In BGP, you can decide path based on X. If X is not okay with you, you can use Y attribute. If your Y is not okay with you, you can use another attribute. So there are a lot of metrics. We call it as rich metric or attributes. BGP path selection is based on the attributes. Now, before taking into different classification of attributes, before understanding this, I would like you to show the attributes list first. These are the attributes of BGP. These are the attributes of BGP, and this is very important, and this has to be learned and memorized if possible in order, because the path selection criteria happens from top to down approach. It will try to match with this. When there are two paths to reach a destination and you need to choose one and leave the other one, first it will check which one has got high weight, and that will be chosen. If both are having same weight, then there is a tie. It goes to the second one. If there is no tie on the first one, it won't come to the second one. It checks local preference. We will discuss what is weight, what is local preference in some time. But I want to just introduce you I want to give you the picture of what we are going to do for another 1 or 2 or 3 hours. So local preference is another attribute. If local preference is higher than the one route of local preference is other than the other route, then the one with the highest local preference is preferred as the best route. The other one is just ignored. If there is a tie in this, then it goes to the origin. Locally originated routes have got more preference than learnt one. Locally originated means I'm a router, I'm advertising 3.3.3.3. That is locally originated. I'm advertising it, but there is also another neighbor giving me 3.3.3.3 from somewhere. Now, which one I should prefer? Should I prefer my own 3.3.3 or someone's network which is coming from somewhere? I should trust my own. I should use my own. That's the reason why I have it. I have 3.3.3.3 so that I can use it. Now I cannot pick the 3.3.3.3 of someone else and try going there. I won't find anything there. So local origin is more preferred than coming from remote. That remote can be within the same autonomous system, or it can be from external, the other autonomous system. And most of the people confuses themselves with this one and this one because both says origin, but they are not the same, they are different. This is what we just now talked about. Locally origin, there is no next stop. You yourself is the next stop. That's why 0000. So this is more trusted, this is more preferred than coming from some address 10.0.0.1. If you have next hop address something like this, and you have another one with the next hop address 000, this is preferred, and the one which has got this as the next hop is not preferred. That's the meaning of yes. Yes. Now when we advertise 3.3.3.3 to our neighbor will see 10.0.0.1 as the next hop address in his BGP table, 10.0.0.1 as the next hop, but what we will see in our BGP table is 3.3.3.3 next hop is 0.0.0.0. So this is one thing. So what he sees is our address. Now let's assume this guy also has got his own 3.3.3.3 which has got 0.0.0.0 as next hop, and there is another source coming and saying this information. Which one this router will use? It should use only this, not this. That is what this means. Prefers route originated by local router over the coming one. If there will be a tie in all these three, only then it goes to fourth one. Prefers shortest AS path. That meaning if there are multiple paths to reach and multiple autonomous system to pass through, there may be one path with 3 autonomous system away to reach destination. There will be another path 4 autonomous system away to reach the destination. Which one it prefers? It prefers the 3 autonomous system path, shortest AS path. Or if there will be a tie in this, only then it goes to the 5th one. Origin code. This is different. What is origin code? Lowest origin code. This is lowest origin code than this. This is called I. This is called E. I is lower than E, and E is lower than question mark. So if there will be one route for reaching A.B.C.D with with I, and to reach that same A.B.C.D, there is another route coming with question mark, which will be preferred lower. I is preferred over question mark. I is preferred than E, and E is preferred than question mark, and we will never see E. It's no more. We don't have EGP. No, now we have only BGP. So you will see either I or question mark. Now what is this I? What is this question mark? BGP's own network. BGP's own network. It is not IGP. It is not Interior Gateway Protocol. It is not OSPF or RIP or EIGRP or something. This doesn't mean that. Here it means internal to the BGP, meaning somewhere or locally someone has used a network command to advertise this. If someone uses network command and advertises this network, and you learn it as I. So here I use network command and I advertise 3.3.3.3. So this neighbor B, let's say this is A, B will learn it with I. 3.3.3.3 learned from 10.0.0.1, attribute is I. I means internal. It's not coming from some other source like OSPF or EIGRP. If it is coming from other source, then it will have question mark. If someone redistributes some other protocols route or static route into BGP, those redistributed learned routes will have question mark. So let us say there are two sources. One source is giving you A.B.C.D, go to 10.0.0.1, and it has got question mark. To reach A.B.C, go to 10.0.0 question mark. Another one says A.B.C.D, A.B.C.D, go to 20.0.0.1 I. So which one it will prefer? This will be preferred and this will be seen in the routing table, not this one. And only if there is a tie in that, it goes to next one called MED. Just a minute. If there is a tie in this origin code, then it goes to MED. And what is MED? We'll discuss about all these things after going through this order. I want you to say that this has to be learned in order. We have to, if someone is asking, or if we are checking how the packet will leave our network, we need to know this in order. Only then we can say, this is how my packet leaves. This is how it will leave if it is like this. We can do some proper guesswork. So we need to know this in order. I have seen, when I talk to some people who interviews in USA, who interviews people for L3 level, they ask these things in order. I have seen. So try to learn this in order. It's very easy, very easy. First it will check wait. If there is a tie in wait, local preference. In both of this, highest is preferred. Then what is default? Default is 0 here. Here default is 100. And if there is a tie in this, and it comes to here, locally origin is preferred, then coming from remote, from other neighbor. And if there is a tie in that, shortest AS path. If there is a tie in that, then it picks the one with the lower origin code. If there is a tie in that, then it goes to MED. If there is a tie in that, then it prefers eBGP path over IBGP path. So there are two sources. One is an eBGP source giving you, another one is an IBGP source giving you. So it prefers eBGP over IBGP. And if you go to the next one, it prefers the path through the closest IGP neighbor. This is like OSPF. You have a big autonomous system, a lot of routers, we run OSPF in it. We have OSPF in it, and see which one has got lower metric to reach the gateway. Which path? This neighbor path or this neighbor path? Choose that path which has got lower IGP metric. Lower IGP metric. Choose the path which has got lowest OSPF metric to reach the neighbor. So that's the meaning here. Prefers the path through the closest IGP neighbor, and then prefers oldest route from eBGP path. Now if you have a two source and you have got tie up to this level, and still if you don't know what to decide, it can be decided like this: which came first, which update came first, which is oldest, that is preferred as the best path. And even if there is a tie in that, there are very less chance to have a tie in that. Let's assume there is a tie. Then it goes to it prefers the lowest neighbor BGP router ID. Definitely router ID, no, I cannot say definitely. Router ID, mostly it will be different. Same like OSPF, BGP also picks the router ID from the loopback interface. Now there are two autonomous systems giving you the update, and both the autonomous systems are having same router ID. Let's assume there are chances, because router IDs are picked dynamically, and router IDs are picked based on different criteria, like if loopback is not present, then physical interface, or if manually router ID is configured. What if there are lowest, correct. What if there are two autonomous systems and having two same router ID? Then there will be a tie. Then it goes and prefers this one. There cannot be a tie at all in this. Why? Definitely because it's a public network. One neighbor IP address will be lower than the other one. There is no chance for two neighbor address to have same next hop address. One will be smaller than the other one. So it prefers that. So this is the selection criteria, and this is the order in which we should know. Now if you see this, these things are not under our control. That's why we don't concentrate much on this, but we do up to this level. Prefers eBGP path over IBGP path. What do we do there? And prefers the closest IGP path, OSPF metric. What we can do it there? There is nothing to do in BGP there. If you want to do changes, then you can do changes to OSPF and have different path. And oldest route, what you can do there? Router ID, no, these are all coming from remote. You cannot go and change the remote router ID. That's not under our control. Someone else's router ID, how can we change? This we cannot change. So these are all not under our control. And these are all the things that we can control. We can change the weight, we can change the local preference, we can change the AS path, we can prepend AS path, we can hide some AS path. Those things are coming. Those things are really high level of learning BGP, not really in CCNP level. It's CCI and beyond, we can say. CCI and real world. So we are going to do that in next class. And I is preferred over E and E is preferred over incomplete. So this also can be to an extent manipulated, and MED can be manipulated. So these are the metrics that we are going to concentrate for today's class. 11 metrics, out of which first 6 we are going to concentrate. Now, out of those 11 metrics, there is again an overall classification like this: well-known, mandatory, well-known, discriminatory, optional, mandatory, optional, discriminatory, optional, transitive, optional, non-transitive. So there are, again, overall classifications like this. Let's see what it is. What is well-known attribute? Well-known attribute is nothing but the attribute that must be there. Sorry. Well-known attributes are the attribute that is seen, popular, everywhere. See, well-known means what? Popular attribute. Well-known attribute meaning everyone knows. Yeah. Next hop, yes. Next hop is a well-known attribute. Definitely BGP means there will be a next hop. BGP update means there will be a next hop. Definitely. That is there in Cisco, that is there in Juniper, that is there in HP, that is there in 3Com, it is there everywhere. BGP means there should be a next hop and it will be there and it is popular. Everyone knows it. And those attributes are all propagated to the other neighbors. Next hop addresses are propagated. AS numbers are propagated. They are all well-known attributes. They are popular. And in that well-known, there are some attribute which is considered as mandate. It should be there. And there are some attribute that need not to be really there. If it is there, okay. If it is not there, also okay. Discriminatory. Well-known mandatory means it must be there. You cannot have any BGP update without a next hop address. If you have, then it's not a valid one. Cannot be taken and processed. If there is an update without a next hop address, cannot be processed, cannot be taken in. It is mandated. AS path, there is an update coming without an AS path, cannot be taken. Well-known discretionary attribute means, it may be there, may not be there. Maybe, may not be. So example for this one, let's say, what shall we say there for this? For discretionary means this origin code. There may be there may be question mark also. If I is there, decide. If I is not there, decide on the other option. So it's not mandated that I always need to be there. If it is there, I take this decision. If it's not there, I take the other decision. So may be present in the update. Yeah. Yes. It can come from local or it can come from remote AS. Whatever, if they used network command anywhere in the globe, they used network command, network and advertised. Instead of, you can advertise the route in two different ways. One via redistributing, the other via network command. So if you use network command anywhere in the globe, any autonomous system, it is I. So anywhere in the globe, if a network is injected into BGP through redistribution, then it is question mark. I is always preferred over question mark. Why? Because I is BGP's own network. It need not to be in the same autonomous system. When I say own, it doesn't mean the local autonomous system. Means BGP's network. So there is another classification called optional attribute. Means they are recognized by some implementations, like weight. There is an attribute called weight, WEIGHT. It's a Cisco proprietary attribute. It is not popular. It is not well known. Only Cisco routers know about this attribute. So they are recognized by some devices. Could be private, as I told you. This is private for Cisco, but expected not to be recognized by all BGP routers. Yes. Yeah. Next is recognized optional attributes are propagated to other neighbors based on the meanings. You will understand this meaning when we go to the other slide. Next 2-3 slides. Next, in these optional attributes, there are two kinds again: transitive and non-transitive. Transitive means the optional attribute only, but if it is there, one meaning. If it is not there, the other meaning. If not recognized, mark as partial. If it is there, then it is complete. If it is not there, mark as partial. And propagate to the other neighbor. But there is another one called non-transitive. If it is not there, discard it. Don't send it. If it is there, send it. Discard it if not recognized. So in the optional itself, if recognized, it is considered as complete. If not recognized, it is considered as partial. Here, if not recognized, it is discarded. If recognized, allow. So these, the one with star, they are called as well-known mandate. It should be there. You cannot have any update without these three, and it's very popular with all vendors. AS path. This is not the order. Don't see. This is not the order. This is not the order. This is just, they have written not in order. So AS path next up origin code. Origin, not origin code. Origin. So these are mandate, and these are well known. You can see in every vendor. Local preference, MED. They are well known, but they are not mandate. Local preference is nothing but locally preferred. Which one is locally preferred? Local means here. Local means autonomous system in which this router is processing the update. So we will talk about this in detail in coming slide. MED stands for multi exit discriminator. Multi-exit discriminator. When you have multiple exit, you want to prefer, see, because of the word exit, people always get confused here, but it is not really something related to the packet that leaves. It is related to something the packet comes in. We'll talk about that in detail next coming slides. So the others are under not our control, so we don't mind. AS path attribute, though it is not first in the order, they have kept it as a first in the order because most of the time when we don't tune our attributes, path selection will be based on the shortest AS path. That's why it is path vector routing protocol, BGP. That's the reason it has come first in the explanation order, but it is not the first attribute. First attribute is weight. So what is AS path? When okay, here is an example. When this network is advertised from A and learnt on C, C will learn like this one. 192.168.1.0 learned from 64.520. When this is advertised here, it will be learnt as this. The last one always says from where it originated, and the other one shows the path through which it has come, like this. This is learnt from 65.500, and 65.500 is learned from 64.520. Next hop attribute. This story we already know. What is that? This 172.16.0.0 is advertised to B. So according to B, who is the next hop address? 10.10.10.3. But when the same network is advertised to IBGP, from B to C, the next hop address still remains the same. 10.10.10.3 will be the next hop address for 172.16.0.0 on router C. That is what this means. It keeps the EBGP's next hop address. And this is again another example for a next hop attribute and well-known and mandate attribute. It's a next hop attribute, it's a well-known and mandate. It's a well-known and mandate attributes. Now this is AS path. There is no option here to select a best path. Here this slide is not explaining us how the path is selected. These slides are explaining us what this attribute means. What is AS path means? AS path means the path through which the network, the AS autonomous system through which the network is being learnt. Only that much is what this slide explains. It's not talking about any tuning stuff, path selection stuff. Those things we will be doing practically. So we are here understanding what AS path means, what next hop means, and what origin attribute means. So do not compare any scenario. Don't take it as scenario and try to do some path manipulation here. Nothing can be done with this. Yeah, we don't have multiple paths here. We don't have. So next hop is also done. Origin attribute, as I already told you. Next hop, okay. Next hop, we remember we learnt there is someone called I forgot the name and all. There is someone called Madhu. I don't know why unnecessarily names and all. Now you are up to the mark. So this 172.16.0.0 from router A is advertised to B. When B learns it, it will have the next hop address as EBGP's address. So on R3 it will have 172.16.0.0. Next hop will be 10.10.3. Now what will be the next hop address when RB gives to RC? What will be the next hop address here on RC? It is the same. Only that much it explains, nothing more. What does it, this is a known story. No, that is next hop self command. That is okay. Here they are talking about default behavior. How the advertisement happens and how the next hop address is kept. That's what. So this is called well-known mandate attribute. There must be a next hop address. Whether it is reachable or not, there should be there. In BGP update it should be there. Next is origin attribute. Origin. Always I is preferred over E. We don't have redistribution from EGP. There is no EGP now, so need not to worry about this. And we got a network command. If somewhere in any autonomous system or in local autonomous system, if network command is used to advertise a network, then those networks are learned on other routers as I. IGP, internal to this BGP, internal to this BGP. And if somewhere if it has been redistributed from other IGP protocol like OSPF, this IGP is interior gateway protocol like OSPF, but this IGP is not interior gateway protocol. This means interior to this BGP gateway protocol, interior to this BGP. This is OSPF or RAPE or EIGRP. When you redistribute routes from IGP protocol or static route, then they are incomplete. They are having question mark. So which is preferred? Always lower is preferred. I is lower than E and E is lower than question mark. Lower is always preferred. The origin attribute informs all the autonomous system in the internetwork how the prefix were introduced. Was it introduced using network command or through redistribution? How? So if it is through redistribution, one source says through redistribution, the other source says network command. Always the network command is what preferred. And this is also a well-known and mandate attribute. Right. Now, just take a minute, 1 minute, and have a look at this table, BGP table. It has got all attributes here. All attributes. So here we... No, it's very simple. Not at all complicated. In another half an hour you will feel nothing. Okay, this is nothing. That's all you'll feel. So you saw that 11 attribute, right? Those 11 attributes can be tuned in different way to have different path selection according to our policies. Nothing more than that. Now, you see, this is a well-known and mandate attribute. Next job. AS path is again another well-known and mandate attributes. And MED is nothing but metric. It is MED. Multi-exit discriminator. Local preference. Weight. AS path we have already seen. So we have seen AS path, we have seen next hop. But we have not seen these things we are going to see now. Now I was talking about I and question mark. Here you see all are I, which means they are coming from other autonomous system. Sorry, they are coming because they were introduced by using network command on this autonomous system. This network, which network? This network. So this network has been introduced in this autonomous system by using a network command. That's why we have I. So it clearly shows the path from where it started and where how it has come, via which it has come. And for this network 10.254, this is the origin. Actually it origins from this autonomous system. These two are same, but it is learned through two different paths. One directly from this autonomous system from this neighbor, another one from the other autonomous system, and then in the middle and from this neighbor. Now when we have multiple source, there are two sources for this single network. There are two sources, one having only one AS path, another one having two AS path. Which one will be preferred? Lower AS path is preferred. First of all, according to our order, it will check the weight. Both are having same weight. There is a tie. If the weight is tie, then it will go and check the local preference. No local preference for both. So there is a tie. Meaning they are locally origin. They are not coming from they are coming from EBGP. They are not locally origin. They are not given by IBGP. They are learned from EBGP. So there is no local preference. We'll talk about local preference only, then you will understand why there is no number here. So in both there is no number, no local preference. There is a tie. Then it will check the origin code, and both are having origin. Both are originated from some other source. No, nothing is from local. Local means you will have this type of number. So there is a tie again here also. Then it goes and checks the origin code. Both are having I and I. Again there is a tie. So what is the next one? AS path. Lowest AS path. This is not lowest. This is 2 number. This is shortest AS path. That is the reason why you have greater than symbol here. Valid and best. You are not having greater than symbol here. So this path is not currently being used. This is used because of less AS path, because of less autonomous system in the path. If this goes down, then there is a chance for this to become the best path. Alright. So here if you see, there are 2 sources from where 10.1 is learnt. One local, another one coming from somewhere else. So what it prefers this local than the other one. Now local preference is another attribute in the list. If you see local preference is there in the second. First is weight and second is local preference. Now local preference means what? It's an attribute which has got scope only within the autonomous system. It has got scope only within the autonomous system. Now every router in this autonomous system should go via this path to reach this network. That is your condition. That's your policy. See, this is shortest actually. How many ASA you have? 1, 2 jump. But you don't want to go like this. According to your company policy, you need to take a long route. You want to take a long route. What may be the reason? Here it is just 1 Mbps connection. Here 5 Mbps connection. So you want to take this route, though it is long route. You want to take this route because of huge bandwidth. But BGP is going to say I'll take this by default because of less AS. So what we do is we tell to our routers here, local routers, we tell to local routers to choose this as a preferred path. How do we say that? We say that by setting the high local preference. The default local preference on every router is 100. Higher is always preferred. Somewhere it should be written. Okay, here. Highest local preference is always preferred. So when I go to this R2 and say, when I go to this R2 or RA, when I go to this RA and say neighbor 10.0.0.1 and then local preference is 200. When I say this, what happens is this information will be shared to everyone in the autonomous system. You no need to go to every router in the autonomous system and tell that prefer this path. No need to say that. You just tell it to one router, that will be shared. That update will be shared within the autonomous system to every router. So the scope of the update is also within the autonomous system. See, within the AS only. Local preference is sent to IBGP neighbors only. It will not be sent. The local preference value that you set in one router on this autonomous system will not be sent to others, but it tells the routers in this autonomous system how the packet should leave the autonomous system. How the packet should leave the autonomous system. If if this direction neighbor has got more local preference, or if this router has got more local preference, then that router will be preferred to go instead of going like this. Why local preference comes into picture? Because that is there in the order second. Only when there is tie in this, it can come and check the shortest AS path. We got local preference on top. So when you tune local preference, it will not pick the shortest AS path. If you don't tune local preference, then it will pick the local AS path. It will go like this. When I tune my local preference, it goes the other way. It goes the other way. So local preference is the attribute that helps to tell our autonomous system how the packet needs to leave, how the packet should leave, how the packet should leave their autonomous system. And this local preference by default is 100, higher is preferred, and we need not to configure this on every router in the local autonomous system. You configure on one router, and every router will know that that particular router is what preferred exit. And this is well known and discretionary. The why it is discretionary. If you don't set this 200, still it is valid. It will go like this. Still this is also valid neighbor. If you set it, it is going to go like this. If you don't set it, it is going to go like this. Yeah, you have some question. No, don't worry about the configuration part. Now there are two ways on doing doing it. You can say on RA you can say this neighbor, and whatever the route that I learn from this neighbor, means I am going to say in direction. Whatever I learn from this, I give more preference. So because you learned like this and you got highest preference, all packet will go via this way, because the routes are been coming like this, learned like this, are preferred more. So those routes will be used to leave the autonomous system. Now do you have confusion in what I said just now? Yeah, all will be neighbor. There is no doubt in that. All will be neighbor. Yes. See, whatever you learned up till yesterday, it's still there. We are not learning something overriding those stuff. There should be BGP. Everything should be there. On top of it, we are tuning the attribute. Why we are tuning the attribute? You don't want to go with the default path selection. Default path selection is like this. Less AS, only one AS. But you don't like to go because this way is bandwidth is too less. It is narrow, 1 Mbps. But if you take this route, it is 5 Mbps. You want to go like this, though it has got too many autonomous system in the middle. So how you will do it? If you don't do anything, then packets are going to go through narrow path. I don't want. I want to go like this, a broad route. So we tune it by setting high local preference. There are two different ways in which you can do it. No, three different ways you can do this. You can go to this router and say you are the preferred router. So whatever learnt by these routers from this neighbor will be preferred than learning from this neighbor. See, this network is given by A to this alpha router and also given by B to alpha router. Now which one alpha router should take, it depends on the local preference. Is this guy highly preferred or this guy? By default both are 100, so it will go with the AS path. And if you go and change the local preference of this, router A has 200, so he has got high preference, so I'll go this way. Is that clear? Right. Next is MED. See, this one I can say 90% of people who have finished CCNP, they're not clear. 90% of people are not clear with this topic, MED. Now, I'll just give you one shortcut to remember. Local preference tells how the packet should leave the autonomous system, how it should leave, whereas MED tells how the packet should enter. It says how the packet should enter. This is enter, this is exit. That's the main difference. So what is this? MED. Now in the order, if you see, MED is here in the 6th place. Only when there is a tie in the above 5, MED can be used in path selection. Now MED is not talking anything about local. MED is talking about the neighbor, EBGP neighbor. See, this is an EBGP neighbor to C and B. Now A wants to reach this network 172.20.0.0. A wants to reach 172.20.0.0. There are two paths in which it can reach. One via B, another via C. Now, I want A come via B. I means this autonomous system 65500. I want autonomous. This is my autonomous system. I am seeing that traffic is coming through C from outside. I don't want that. I want traffic to come through B to reach 172.20. I don't prefer coming via C. Only if B is unreachable, they can come via C. Now what I do is I set low, smaller MED value than the other one. So this influence the path chosen by the neighbor. Means, EBGP neighbor, external neighbor. Local preference is not going to influence the external neighbor. Local preference is local to the autonomous system. It is within the autonomous system. It is local within the autonomous system only. Whereas this one tells the next autonomous system how they can come in. This is an optional and non-transitive attribute. It is non-transitive. It is not sent to all the neighbor as an attribute. It tells only the directly connected by saying if you come through me, it is 150. If you come through me, it is 200. You decide which one to choose. Then this will say I'll come through you because you have got lower MED. In MED, lower value is always preferred, most desired. Whereas in local AS, higher is preferred. MED lower is preferred. Now what is the default MED? It's 0. Default MED is 0. I'd like to see, I want you to see that here. See? The default local preference is 100. Default weight is 0. We are going to see the default weight. Autonomous system. No, it will not be first of all sent out. When EBGP sends an update, when a router sends an update to an EBGP neighbor, local preferences will be filtered right here itself. Local preferences that comes, it will not be transited. The scope of that attribute is local to the AS. Yes. If you no. See, you always think about this one. Your autonomous system. This is mine. I want to decide how I should go. This is for that I use local preference. Again, now this is mine. I want to decide how others should come in. Then I go with MED. This is for me to go out, and this is for others to come in. So depending on our need, we pick one and tune it. You don't have any policy related to coming in, traffic coming in, then you don't need to worry about MED at all. Just leave it default. Because there is a tie, it will go and check with the next in the list. In the list, the next is eBGP path is preferred over IBGP path. If still tie, goes next. Depending on policy. So don't consider this and this as your autonomous system. Don't consider this as your autonomous system and try understanding this topic. Then we'll go opposite, we'll go wrong. Why it is called multi-exit discriminator? I have got 2 exit, but not for me to exit, for others to come in. That's where people go wrong with this topic, because it is having E there, exit there. They think packet leaving out. No, it's not packet leaving out, it's packet coming in. Which path they can choose to come in to talk to this network? This one, if you prefer, then give low MED, or if you prefer this one, if you prefer B, leave it 0, let it be 0 and give some higher number here. Automatically this will be preferred. MED is used to advertise eBGP neighbor how to exit their AS to reach the network owned by this autonomous system. See, this words are not really confusing, it looks like confusing. There, avargal. For me, their network. MED is used to advertise to eBGP neighbor how to exit their network, how to come out of their network, how to exit their AS to reach the network owned by this AS. This is where MED is configured. Right. And then the MED attribute is an optional and non-transitive attribute. It's an optional and non-transitive. Weight. Weight is a Cisco proprietary attribute. It is seen only in Cisco. And this weight is not same like AS, but partially it is same like AS. How? Weight has no scope with other AS. Weight is only local to router. For this router, I want to go like this, not for the entire AS. For this router to decide how to go to reach this network, I want to take this path, not the other one. Then I give higher weight here. It goes like, yes, you can write an access list and call the access list under route map and say when this access list matches, give this weight. So it will go like this. The other networks will go like this. You can do it. We are going to do that. Right. So far what we have seen is, we have seen weight, which is configurable. We can configure MED, we can configure local preference, we can configure origin, redistribution. If redistribution, then question. If it is network command I, that is also under your configuration, depending on our configuration. Next stop, definitely it should be a reachable next hop, otherwise you say next hop self. So that is also under our control. Next hop is also under our control. And AS path, you can really tune AS path also. You can tune AS path also. Let me give you one example which we will be seeing in day after tomorrow class, not exactly on tomorrow. Now because we have a long way to go there. I don't want to go like this to reach this, but I want to go like this. There are two ways that you can do it. Okay, let me put in a different way. It's not going out, it's coming in. The updates, when 172.16 comes here to B, on B, router B will be learning it from two autonomous system. So B will say 172.16.0.0 learned from 6500, and that has learned from 65350. So because it is coming like this, B prefers to go like this. Because the update is coming with lower AS, this is giving 3 autonomous system, this is giving just 2 autonomous system. Now what I can do is, I can go to this router. I can go to this router and say, before you send it out, before you send the update out, put your autonomous system 5 times. 65350, 65350. So it has put 3 times 65350 repeatedly and sending here. Now this 65350, the 65350 is 3 times. So it looks like 3 plus 5, 5 hop away. Actually it is only 2 hop away. So you can tune the AS path, you can add, you can prepend, you can do some changes to the AS path according to our wish, and make B not to come like this. See, depending on the policy, local preferences, how to leave. Now MED you can use to say not to come like this. There is also another option. You can tune local AS, sorry, you can tune the AS path. You can prepend some garbages in the middle and show to the neighbor as if there are too many A's in the path, so that these guys will not take this path. There are many ways in doing it. Now those advanced stuff we will do it later. Now we are trying to understand this level. But as for interview, whatever you are going to see till today is what important. Very less chance for you to get questions on what we are going to learn tomorrow, day after tomorrow. Mostly it will be only up to today's level. So this class is very important, and the video that I am going to give after this class is very important. I think I already gave you AS path. After listening to this class, you go through that lab video, and if you have any problem, I will also do tomorrow. Right? Let me finish the theory alone today and go through the lab in the AS path video. Whatever I'm saying here in theory, I have explained with the proper example there. Local preference, weight, origin code, all the stuffs are explained there, except MED. MED, in that topology we cannot have MED. For practicing MED, you need to have this type of multiple exit. In our topology we don't have multiple exit. Our topology that I shared with you has got one AS like this, one AS like this, another AS like this, another here, that's all. So there is no multi exit. Okay, yeah, we can do here. If you want, you can do MED here. You have one network here, 1.1.1.1. I want 6.6.6.6 to come like this to reach 111. By default it will come like this. Why? 1, 2 jump. But I want it to come like this. So I go here and set MED. I go here and set no, again it is 2 different AS. It should come from one single AS. So if you combine these two as one AS and I got 2 exit and 1 router here, like this. Then you can practice MED. Our topology doesn't support MED, so I am not showing MED, but I still show the command how to enable MED in that video. Have a look on that. So MED is local to the router, and again MED by default is 0. By default it is 0. Higher is always preferred because this has got high weightage. Sorry, what I'm saying, weights. By default weight is 0. It's a Cisco proprietary. Higher is always preferred. More weightage to this neighbor. So whatever I learn from this neighbor, I give more weightage. Same thing I may be learning from here, but because the weightage is lower for C, I don't prefer that way. I prefer this way because of the weightage. And this is not for the entire AS. The scope of the attribute is only within the router, only for that router, local to the router. Whereas local preferences, you just set in one router, it will be spread to all the router in that local autonomous system. That's the difference here. How BGP path selection happens? BGP forwarding table usually has multiple paths from which to choose from each other. We saw an example here. It has got multiple paths. Here for each network you have 1, 2, 3 multiple paths. You need to pick one by checking the attribute. Let's see how this has been selected as valid and best. There are other two. Why this is not selected? Let's see why. Okay, all three has got next hop. There is a tie. After next hop, what it will check? It will check the weight, and all three have got 0, 0, 0. That's the first attribute. 0, 0, 0. There is a tie in the weight. So if there is a tie in the weight, then what it will do is it will check the local preference, and the local preference is 100. No local preference. This is coming from eBGP. This is coming from eBGP. If there is no local preference, it means it's coming from eBGP. And how it comes from eBGP? Okay, this is again mistake actually. Same number 2 times. It's a mistake. Now next is there's a tie in local preference. Then it will check what origin. There is no local origin. If there is no origin, then it will check AS path. No. After origin is AS path. Yes, correct. After origin is AS path. So it was checking. It will check AS path, and AS path also same 2 hops. So there is a tie, and it will check origin code. Both are having I and I. There is again a tie, and there is no MED. If origin code is tie, then it will check MED. MED are also nothing. Blank. There is no MED set. There is no MED also set. And because there is a tie in MED, then what it will do is it will prefer eBGP over IBGP, and both appears to be an eBGP, no IBGP. And then next is it will check the shortest IGP path to reach the neighbor. That we cannot we cannot decide based on this table. We need to check the metric of OSPF. So if there is a tie in that shortest IGP, closest IGP neighbor, then it picks the oldest route from eBGP. This also you cannot, because there is no timer here. There is no timer here, but internally they maintain the timer, whichever came first. If this would have come first, then this is the valid and best, if not the other one. And let's assume the timer is also same, both came and formed neighbor same millisecond, assume. Then what it will do, it will check the lowest router ID. Router ID we don't have a clue here. Let us assume there is a tie in router ID also. At last the option is smallest IP address. This is the smallest one. This is 11.4, this is 1.3. Definitely this is smallest. So for that reason also I can say this is valid and best. So we have seen all these 11 steps. Mostly that selection may be because of this or this. Assume there is a tie in all this. Still this is getting true. Smallest one. So this is how the path will be selected. Now I don't like this to be preferred. I don't want this to be best. I want this to be best. Then what I can do is I can change MED. If it is only for this router A, I can change MED value here. I'll give 10. Sorry, not MED. Wait. I'll give 10 here. Higher is preferred, always wait. Then this will become valid. I don't want to just influence one router. I want to influence all the routers in the autonomous system. Then what I'll do? I'll give here local preference as by default it is 100 internally maintained. I'll say 110, and this is by default 100. So 110 is bigger than that, so this will be preferred. So this becomes best and valid. 1 2 1 2. This is only 1. This is coming from no. This is coming from next neighbor. If it is internal, there won't be AS number. See, there is no AS number. Right. So all these are eBGP. So this is very important, and that's all about AS path. The next chapter is the final chapter in CCNP level. This talks about the lab that I am doing in the video. That will be better than going through this PowerPoint. It shows the command how to set local preference value, how to set local preference using route map. No, more than this, my video will be better than going through this. How to set MED value, default metric, how to set not that much they have shared, but